This video is going to show you how to calculate concentrations of solutions. So we're going to look at the concept of molarity and then how to create different solutions using dilution. So what concentration is the measure of the amount of solute dissolved in a solution. And these solutions can fall into two categories, either dilute or concentrated. These terms are relative. What might be dilute to one person could be concentrated to another, or they could be relative to the situation. Here you can see in the diagram that you've got dilute solutions on the left with a little bit of color, and then concentrated solutions on the right. Generally speaking, though, a concentrated solution has a high concentration of solute in relation to the solute. Okay, so it's a ratio of the solute to the solvent. And that's pretty much what we're going to be looking at mathematically. So we can compare solutions and express concentrations two ways. Well, actually, there's more than two ways, but two primary ways, either molarity or percent solutions. Now, chemists prefer molarity when they are talking about it, and biologists prefer percent solutions. Since this is a chemistry class, we're just going to focus solely on molarity. So molarity is abbreviated with a capital M, and it is the number of moles of solute dissolved per liter of solution. So if we want to write this as a formula, M equals moles over liters. Okay, so the volume does have to be in liters. A lot of times you will be given milliliters and you are going to have to change that into liters. And so we've done these conversions before. 1,000 milliliters equals 1 liter. You're going to have to do these for this problem solving. So there's our formulas again, written a little neater. Moles of solute divided by liters of solution. So here's our first problem. 2 moles of glucose is dissolved in 2 liters of solution. So here's my moles, here's my liters. So I just have 2 moles divided by 5 liters, and that gets me 0.4 molarity. Okay, often what we would say is we would say 0.4 molar, like that. And but the capital M stands for molarity, and that is the proper number of sig figs. I have 1 sig fig in my problem and 1 sig fig in my answer. So when we're in the lab making solutions, many times the solid that we're dissolving is in grams. We don't have scales that measure in moles, so typically we're measuring grams. A saline solution contains 0.90 grams of sodium chloride in exactly 0.100 liters of solution. What's the molarity of the solution? Well, I'm going to have to take this grams here and turn this into moles, because that's what my formula calls for. Molarity is moles over liters. So that's where we will start. 9.0 grams of NaCl times grams of NaCl, and 1 mole of NaCl. Now, grams, I get off the periodic table. If I add up the sodium is 22.99. The chlorine, 35.45. I add those two numbers up, and I get 58.44. Okay. So 0.90 grams divided by 58.44 gives me 0.01540 and some other numbers, and that is moles. So now we've got our moles. What we need to do is divide by our liters of solution. So let's change our color here, make it a little easier to see. So I've got my 0.015400 moles. Now, I'm not going to worry about sig figs until the end of the problem. Okay, and I take that and divide those two numbers, and I get 1.5 molar, capital M. So my problem only has 2 sig figs with this 0.90 right here. So my answer, I'm going to round to only 2 sig figs. Okay, now this one's a little bit different because this time I've got my moles and I have 125 milliliters. So I need to take that information and change it into liters. So 125 milliliters. Whoops. We don't want that. Okay, 125 milliliters. And I want the same units diagonal down, so they'll cancel. In 1 liter, I have 1,000 milliliters. So that's the same as saying 0.125 liters. And I have molarity equals moles divided by liters. And then you've got 0.25 moles divided by 0.125 liters. And I do the math, and the calculator spits out 2. And I look at my sig figs, and I've got 3 sig figs here in the 125, and I have 2 sig figs with 0.25. This is only 1 sig fig, so I need to add a 0.20 molarity, or molar. So 0.20 molar, or 2.0, sorry. 2.0 molar is the molarity of our new solution. So with this equation, you could also manipulate it around. I'm going to change some ink color here again. Okay, I've got this formula right here, but I can also cross multiply, and I can do molarity times liters, and that will give me moles. If I then take that information and divide it, if I'm looking for liters, I can divide that by M and by M, and what I get then is liters equals moles divided by molarity. So I've got 3 different equations that can be used. Here's 1. Here's 2, and here's 3 different equations that can be used to find me whatever I need. Now, oftentimes in the lab, what we have to do is a dilution. We have a solution, but it's not the right concentration. Oftentimes I buy chemicals in bulk, super concentrated, because it's easy for me as a chemist to add water to it to get the concentration we need. Water is actually heavy. It's about almost 8 pounds per gallon. And so that gets expensive to ship. This is why at grocery stores and things, you tend to buy concentrated solutions. You might buy orange juice from concentrate and then add cans of water to it to dilute it to the concentration you like, to the sweetness that you like. Well, it's the same sort of thing in chemistry. So we need a dilution formula to kind of help you out. And what it does is it reduces the moles of solute per unit of volume. So M1 times V1 equals M2 times V2. A lot of times we'll also just write it like this. M1 V1 equals M2 V2. This might remind you of something. It might remind you of our gas laws. So P2 V2 equals P1 V1. I kind of wrote it backwards there, but you get the idea. So it's going to solve pretty much the same way. Now, volume here does not have to be in liters. Okay, so it does not need to be in liters. It can be in milliliters, it could be in microliters, but you don't have to worry about converting the liters to milliliters again. So here's a problem where we can do a dilution of a solution. How many milliliters of a stock solution of 2 molar magnesium sulfate would you need to prepare 100 milliliters of 0.4 molar magnesium sulfate? So don't worry about the term stock solution. That just means what's in your stock room. And we are doing a dilution, so M1V1 equals M2V2. And again, just like with the gas problems, we need to keep like terms that are paired together in the problem, together in these dilution problems. So you can see here this 100 milliliters of 0.4 molar magnesium sulfate are paired together. And up here, how many milliliters of a stock solution of 2 molar magnesium sulfate are paired together? And just like before, it doesn't matter what you call 1 and 2, just as long as you keep the terms together. So this 100 milliliters right here, we can call this V1, and that's going to make this molarity M1, not M2, M1. And then this one right here would be M2. And how many milliliters means we're looking for V2, our second volume. So since we want to get V2 by itself, I am going to divide by M2. And those cancel out. And what I'm left with is V2 equals M1 V1 over M2. Again, like before, I just think it's easier to move the letters around before you put in the numbers. So here I've got my M1. My M1 is 0.400 molar. My V1, 100.0 milliliters. My M2, 2.00 molar. Okay. And now we can solve. V2 equals, I multiply the two numbers on the top, I divide by the two numbers on the bottom, and I get 20 on my calculator. But if I go back and look at my problem, I should have 3 sig figs. That's only 1 sig fig. Now that's 2 sig figs when I add the decimal, and 3 sig figs when I put the 0 after it. And my units, molarity cancels, and then I have milliliters left. So my V2 would be 20 milliliters. So what this means is I would take 20 milliliters of my 2.00 molar solution, and I would add water. So I'd add water until I get to 100 milliliters, and then that will become a 0.4 molar solution. So I'd actually be adding about 80 milliliters of water to get that diluted down. So that's how dilutions work.